All right, welcome back. We're back, one of the final episodes of DiSco MIMO, probably 1 or 2, 3, 4, not too many left because we wrote half of the paper, so we're in the writing stage. Thanks for watching on YouTube, thanks for following. Don't forget to sub on YouTube, follow on Twitch, you know it. Let's get back to writing, straight to writing, okay? So let's finish writing about sampling because we did find some differences here. Okay, remember what I want to write about is that the parameters were messed up in the original code and we had to meddle with the initialization too and the beta coefficients. So capacity allows us to quantify reproducibility gap between MATLAB shown by dashed lines. It becomes clear, it's clear that the two distributions are significantly different. And despite our best efforts, we were unable to reconcile the Sionna simulator with the MATLAB behavior, mostly given that MATLAB itself, because of a lack of MATLAB access. Moving forward, we heavily favor Sionna because of its open license, because of its permissive open source license and native Python packaging. Okay, so we're gonna diss MATLAB here a bit. It's clear to despite our best efforts, we were unable to reconcile lesson learned. Maybe we should do some lesson learned type of things in LaTeX. We favor Sionna for scientific MIMO channel research because of its due to its permissive open. Okay. Figure once we accepted the training distribution gap, moving past the training distribution gap, the training data distribution gap, figure 2 reveals other interesting reproducibility aspects in this particular application. Let's just comment them as items, right? So begin, oh my god, itemize. Oh my god, come on. Okay, item 1, item 2, item 3. Score-based generative model sampling is highly sensitive to hyperparameters. And there is a dual mode behavior we uncovered when inspecting the legacy code base and comparing it to the paper. they each report a different set of sampling hyperparameters. Okay, the sentence is getting too long though. Let's pull it into a... This experiment shows that score-based generative model sampling is highly sensitive to numerical hyperparameters, and there's a dual mode behavior. The legacy code base uses two hyperparameter values of, I guess we'll have to just name them here. Alpha is 3 times 10 to the minus 11, and beta is 0.001. While the paper recommends following the automated procedure in song. Despite this, when implementing this procedure is not implemented in the code base, in the legacy code, and following it yields hyperparameters of alpha approximately what was it, 125 times 10 to the minus 8, beta 1. Despite the 3 orders of magnitude difference in alpha, we find that both sets of hyperparameters produce synthetic data of reasonable quality. Holy shit, the writing is, we're writing so much now. I'm worried we're running out of space. Okay. Figure, fig CDF plot. Summarizes this through the 3 solid line plots. Through the 2 solid line plots from the reproduced setting. Following the paper yields a distribution very close to that of the Sionna of the training data in the modernized code base, while following the legacy code base settings, produces a slightly different data distribution. This is validated in the legacy code base itself by regenerating synthetic data, green curve in figure, and noticing that it also deviates from its own training distribution. To conclude, we implemented a clear, our modernized CLI now takes all these parameters, including an auto option for determining them according to, takes all these values as optional inputs, allowing researchers to systematically experiment across them. Okay. Regardless, our modelized CLI code base, CLI equipped code base, okay, I think we're done commenting on the results. Like, this is as much as we can do for 4 pages, right? So we noticed a bunch of differences. We'll review the writing later. Now, let me talk about I'd like to, oh shit, no, wait. Reveals other interesting results in a particular application. Well, this is enough. Another interesting reproducibility aspect of this particular application. We found that and exhibits probably have room to write more here. Interesting. Report a set of the legacy code these values. Okay. All right. So we should let's see. Let's not space too much here. For the 2 training sorry, we use 10,000 samples, the entirety of 10,000 samples to estimate the CDF. Whereas for synthetic data, we generate 300 samples with each method, given the sampling costs. Given sampling requires us to run a multi-stage step deep neural network inference. Okay. All right, so let's see what we have here. Okay, so I think we're done with this section. Oh, sorry, my throat is on its way out. What we need to do now let's write about the modernization that we did. I don't think we're gonna have room for tables, so we can ditch these. Maybe we'll see. Our primary goal is to modernize the code base and make it significantly more accessible to researchers. We identify and we identified the following high-level desiderata, okay? So what did we want to do? And tackled. Well, first, we need to get rid of MATLAB dependency and move to a full Python solution. Given that MATLAB has no official Python bindings and its expensive licensing costs, we strongly favor. Well, let's see. Does MATLAB have Python bindings? I gotta be careful what I say here because I don't want to get myself banned. MATLAB Python. It does have MATLAB engine API called computation engine from Python. Hang on, I gotta get some water. So maybe we say about dependency. We want a cross-platform log file centered based approach for dependency management. Dependencies should be fully resolved and have exactly specified versions. Okay, so what are Python log files? UV log files. Let me quote UV then. Okay, so I can do a footnote and I can do URL this. Let's see how this looks. sync and lock file based approach. Dependencies should be fully resolved and have exactly specified versions, ideally across all platforms: Linux, Windows, or Mac. So we want this. Saying we need to get rid of MATLAB is it's not a desiderata, it's a consequence of this. Now, what else did we want? A CLI. A research friendly command line interface for the main applications a researcher would run. Training and sampling from a score-based generative model. We want the CLI to encode sufficiently many hyperparameters such that users make 0 changes to the code in the initial exploration phase. Okay, so 0 changes to code. So we need a CLI. A key component for answering the first desiderate, what? Desideratum? Jesus Christ. For the first desideratum, is a Python dependency management software. We choose UV. All right, so let's cite UV. How would you even cite UV? I guess we'll do them a favor, we'll cite them. Okay, so it's Astral. Well, they got bought by OpenAI, sure. So I guess we'll put them here. 2026 title UV. I'm extremely fast. Python is written in Rust. Okay, so we can cite UV. We chose UV due to its powerful feature set and cross-platform compatibility. A first major advantage is that UV manages Python installations by itself across platform which relieves the burden, which relieves users of having to track multiple Python versions, multiple track and refer to multiple Python installed, multiple Python versions installed on the same machine. Subsection, modular. The first work item was to refactor the code from loose.py scripts at the root of a repository into a to a proper Python module. Project structure. Actually, I can, let's see. I can do a subsection, right? This is easy. This is easily done by running uv init Python version which produces okay, so we moved everything to src MIMO. Oh my god, I'm already at page 3. Holy. Alright, gotta take a quick break. We'll be back. So we have to write more about this. We have to write more structured. All right, we're back. Actually, I realized we may need some toml code listing. So let me see. Overleaf toml code listing. Okay. So let's see, can I do this listing? Maybe this works. Okay. And I need use package listings. Oh shit. Minted. And what does it want? Does this work? Maybe. I don't have free account. Yeah, I can't do this. Oh, come on. So now it won't let me even compile this? Oh, shit. Damn it. I need to ask Gemini because this is wrong. Damn it. How to highlight toml in LaTeX listing. It's not a standard language. I need something clean, minimal that works with free overleaf. Fast compilation. I can't do like weird shit, dude. Yeah, so we can define our own language. Although I'm worried this will slow. Oh my god. Okay, I don't even know what the heck this is. So can I do toml now? Kind of. Yes, I can do toml. Oh, interesting. Okay. Oh, what? Font shape. I mean, yeah, there's some weird shit here. Jesus Christ. Okay, I guess we'll take this. All right, so this is augmented by running uv init, which moves all project packaging and dependency management to a by project toml file with the basic skeleton, with the basic configuration shown in listing ref whatever label lst toml basic. Yes. Let's see how this looks. Let's okay, so it's not too bad. Okay, I've seen worse things in my life to put in a paper. So now let's just copy from our code. So what's the basic? Project. We can cut some of this stuff here, right? Name MIMO. Oh my god, I forgot to, sorry, I wasn't sharing the thing. Sorry, I was writing this paper all this time. I was stuck on VS Code. Thanks for sticking around or joining. So we're writing this research paper. We're at 3 pages out of 4. We're kind of running out of space. All right, so I have to cite Sionna, NVIDIA, which is interesting. Do they have a citation? Yes, they do have a citation. Good. So very good of them to have a citation. Oh god, but this is like ancient, dude, like version 2. Oh my god, I don't even have version 2. No way, they just migrated this to PyTorch. This undermines all the work I did. Hilarious. I guess we'll reference the old version. There's nothing else I can do. This is actually hilarious. Okay, so we have to write the paper about Jesus Christ, dude. We have to write the paper about version 1.2.1 because I'm gonna go insane. This is so funny. Damn it. Sionna library. A native Python library. However, this brings another dependency challenge. As of the time of writing Sionna 1.2.1, the latest Sionna version that we considered when starting this work was TensorFlow based, and its dependencies were incompatible with PyTorch specifically because of numpy 1.x versus 2.x issues, backwards compatibility issues. Fortunately, UV comes to the rescue once again, has a feature made exactly for this case in the form of exclusive dependence of incompatible dependency groups. We should cite these. Let's see, dependency groups. So incompatible, what is it called? Exclusive. Where the heck do I see this? Where did I find those things though? Oh, come on, man. UV exclusive dependency groups. What feature did I use? Oh, it's conflicting. Conflict? Yes, declare them as conflicting. Here it is, conflicting dependencies. All right, so we need to cite this form of conflicting dependencies, right? Dependency groups. And then I can do a footnote, URL this. We use this feature to allow Sionna and PyTorch, the Sionna code needed to generate training data, and the score-based generative model training and sampling code to coexist using two separate dependency groups as shown in listing. Okay, the user, the researcher experience is very friendly. And consists of the following pipeline to train and test a score-based generative model from scratch. Of the pipeline, the researcher experience, I should add this here. All right, so I got to write two of these listings now. Oh my God, we're getting close to page limit too. Okay, I can't believe they solved that problem though. This is the dumbest thing ever. So basically Sionna, okay, let's not talk about that. All right. Oh my God, what is this? Illegal parameter number, footnote URL. What the heck is this? Can I not escape this? I can, okay. Design. Solve this by forking the repository. Okay, I gotta write some code examples and I'm on the 4th page already. All right, let's not panic. So we're right. Okay, so listing. So we need a code listing here that shows, what do we say we're gonna do here? We can call this B. It's still toml. Oh yeah, toml get dep. We just want to show people what we did with our and Py project toml section in listing. Okay. Ref lst toml get dep. Okay. This looks good. Okay, so what do we want to show users? I mean readers. I just need this little thing. So I'm gonna do it this way. Dependencies is and it'll depend on NCSN v2, okay, and then we have to show, so this is in the project section, okay, and we need to show how to link it. Yeah, here it is, tool UV sources. So we just want to show the source, okay, which is path to forked and rev commit ID. Anonymized. Okay, so that's it. So if I just tell it to look here for NCSN v2, then pip install just works. Nice. So we're done with one more example. The required section amendment, the required amendments to pip install to make any, to use any properly packaged Python repository as an installable dependency in our project. The amendments required in this case the fork of the NCSN v2 repository. All right, And should I put a dot here? I think I should put a dot, right? Yes. Oh, what happened here? Whoa, 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 whoa. Damn it, I need to escape this. All right, so we have two code listings. And it has a revision. Okay, on to the next one. Sweet Mother of Mercy. On to the next one. Damn, we really need to add more references. Can I find the citation for NumPy? Oh shit, I forgot this again. Man, I'm really doing a bad job with this. Can I find the citation for NumPy 2.x backwards compatibility? Because I know it's really broken. Yeah, it is. Okay, I'm just gonna cite this here. So I'm gonna cite it as a footnote. URL. Psht. All right. Okay. Next, where were we? Oh my god, I still need to find that value. Yeah, we're not gonna have time for tables for sure. We still need to write the intro, but we're almost done with the modernization. Okay, more. Mutually exclusive dependency groups shown in listing. Okay, we're gonna need an example of the dependency groups. Something minimal here. So toml dep groups. Okay, so ref lst. Oh shit. Why? LST toml dep groups. Okay. Two separate two dependency groups. Now, what do we need to show users here? Here, we need to show them the conflicts, Sionna no RT, and Torch. Not be that easy, because these things, they may not have citations. Okay, we're almost done. We gotta take a break. Oh my god, how do I cite OmegaConf, dude? Seriously? I gotta make... So OmegaConf. Is there a title for OmegaConf? I'll just call it a hierarchical configuration system. Okay, so this is OmegaConf. And Hydra core. A framework for elegantly whatever. Okay. And I'll just put it here. Okay. All right. So OmegaConf and Hydra to add a fully featured CLI to our 3 user-facing applications. Data generation using Sionna, score-based generative model training, and inference. The resulting in particular, we use Omega structured configurations which live directly in the Python module files and not in separate .yaml files to improve developer experience by having the configs as close as possible to the code that utilizes them. Okay? The resulting researcher experience, developer experience, rendering consists of a pipeline of a click to run pipeline to train and test the score base to generate training data, train, and test the score-based generative model from scratch, as shown by the 3 sequential commands, 1 for each part of the pipeline in listing. Okay. All right, this looks pretty good. We're approaching the page limit, but we still have some room left to write, so we'll keep writing. Thanks for watching so far. Thanks for follows, subs. This is a good stopping point. We'll keep writing next episode or after a break on stream. Thanks for watching. Stick around.